Welcome to this explainer. It's brought to you by Forge College, and I'm super excited to dive in today. We are getting into our overview of Solana client libraries, which sits right inside the Introduction to Solana Client Libraries module. That's part of our Interacting with Solana Clients and Programs course, all under the Programming with Solana track. Sound like a lot? Don't worry. Basically, we're going to be hooking up the plumbing of your applications to the blockchain today.
So think back to our previous lesson. Capstone build, deploy a functional program entry point. You did the heavy lifting, right? You wrote the logic, you deployed a fully functional program to the network. It's awesome. Congrats. But now what? You've basically built this incredible high-performance engine, but you kind of forgot to install a steering wheel. How do your users actually interact with it without needing a PhD in raw byte manipulation?
Well, here's our blueprint schematic for today. We're covering 1. The void, 2. Core responsibilities, 3. Translator versus traffic controller, 4. Assembly instructions, and 5. Best practices. Let's get right into it.
Section 1. The void. From program to client. You really need to start thinking of the program you just deployed as a strict server API. It's sitting out there, and it expects exact byte-level inputs. It's kind of like trying to order a coffee, but the barista literally only speaks binary. If you're off by even a single 1 or 0, you're not getting a latte, you're getting an error. That huge gap between your smooth, user-friendly front end and the unforgiving raw binary of the blockchain, that's exactly what we need to bridge today.
Enter Solana Client Libraries. These are your language-specific toolkits used to build transactions, query RPC nodes, decode data, and orchestrate signing. Whether you're coding a web interface in TypeScript, a heavy backend in Rust, or running analytics in Python, there's a specialized toolkit waiting for you. They're essentially your universal translators. They take your high-level intent and translate it into the exact raw bytes the Solana network demands.
Moving on to Section 2, Core Responsibilities, what they do and definitely don't do.
It's absolutely crucial to understand the engineering boundaries here. The library gives you a clean connection object, sure, but your application still has to select the endpoints and handle offline fallbacks. For instruction construction, the library gives you helpers, so you aren't packing raw bytes manually, but you absolutely still have to ensure correct account ordering. For serialization, you get great tools, but if your schema doesn't match the deployed program, your transaction crashes. And the big one, signing and key storage. The library provides the interface to sign, but it absolutely will not manage or protect your users' private keys. Secure key management is 100% your responsibility.
All right, Section 3, Translator and Traffic Controller, the mental model.
To really wrap your head around wiring these up, I want you to use this two-part mental model. First up is the translator. The blockchain is stubborn. It only speaks byte grammar. The translator takes your simple request, like mint a token, and maps it to that low-level byte grammar, perfectly aligning the data layouts and required accounts. Then you have the traffic controller. This side manages the network flow. It doesn't care about the grammar. It cares about routing. It manages commitments, simulations, retries, and RPC endpoints.
To help the translator work flawlessly, we use an IDL, or Interface Description Language. It's essentially a schema file used by the translator to automatically generate serializers. Think of it like a Rosetta Stone. Without it, you're literally just guessing how many bytes long a string should be. The IDL saves you from those incredibly frustrating generic runtime errors by perfectly mapping out the data schema for you.
Now, on the traffic controller side, a huge concept is the commitment level. This is an operational control like confirmed versus finalized that dictates network confirmation semantics. If you're buying a virtual coffee, a confirmed commitment is totally fine, it's fast. But if you're transferring a massive asset, you want a finalized commitment. You wait for the ink to dry. The traffic controller uses these levels to manage behavior based entirely on how critical your transaction actually is.
Section 4. Assembly instructions. The setup workflow.
So how do we put this together? It's a simple 5-step blueprint. Step 1, choose your language. Step 2, initialize your connection. You want to set up a shared RPC client here so you aren't opening a ton of redundant connections. Step 3, configure your key pairs. Figure out where the master keys live safely. Step 4, simulate. Always run a drill first. And Step 5, construct, send, and confirm. Pack everything up using your library helpers and ship it off to the network.
Finally, Section 5, Best Practice Patterns, the rules of the road.
Keep these guardrails in mind because they will save you hours of debugging. First, simulation-first development. Always simulate locally before broadcasting. It catches access issues immediately, and hey, nobody wants to pay for wasted signature attempts on noisy test networks, right? Second, use a central RPC client instance for consistent routing. Third, rely on IDL-driven serialization so you aren't doing any of that error-prone manual packing. And lastly, use optimistic reads with reconciliation. Make the app feel super fast to the user instantly and then quietly verify the transaction on the blockchain in the background.
So here is your debugging hierarchy to take away today. Translation first, network second, key management third. If an instruction fails during simulation, it's a translation problem. Check your serializers. If a transaction drops, it's a traffic control network problem. Are you ready to build? Next time, we're getting our hands dirty with the actual installation. Before we wrap up, a quick reminder that this explainer was proudly made by Forge College. Head over to forge.college to learn more about this and other incredible Web3 topics. Thanks for hanging out and keep building.